access the recording on Canvas. All right, so if you kind of remember last Wednesday, we went over something called the sampling distribution, where the sampling distribution is pretty much when we start off with a population and we start sampling from that population. So when we start sampling from that population, we start sampling where we have more than one sample. So instead of getting a sample size of 1, we're getting like a sample size of 5, 20, 30, 40. And depending on the central limit theorem, so if you remember the central limit theorem, you say if we increase our sample size, and usually the rule of thumb, if n is greater than or equal to 30, we're going to say our distribution or our new distribution should be approximately normal. If n is smaller than 30, then we're going to say it's non-normal if they don't tell us the data set is normal. Question?
Is this chapter 8 notes?
Yeah, chapter 8.
What page?
Page 5.
Okay, great.
All right. So if you kind of remember on last Wednesday, if you just look at what I have on the board right now, it said we kind of just spent it on just finding mu of x bar. So if you kind of remember mu of x bar is equal to mu, because our mean doesn't really change. What actually changing is our standard error or our standard deviation of x bar. So to find standard deviation of x bar, we have to use the formula standard deviation divided by square root of n. So we have to use that formula, and that's going to give us our new standard deviation. So you always want to calculate the new standard deviation, because if you can't remember, if the bigger the sample size is, the less error we should have. And that's what the standard error is telling us. It's telling us, hey, if we have a sample size of n many, we have to divide the sample size of n many into our standard deviation. And that's going to cause our standard error or our standard deviation to get smaller. So if you remember this one, we originally started with a standard deviation of 6. But we're saying if we have a sample size of 20, then our new standard deviation is going to be 1.3416. Everybody good so far with that? Okay, so up next we're gonna go ahead and we're gonna be finding the probability of this normal distribution. So we're gonna go ahead and find the probability. It shouldn't be anything different. We're still gonna use the function, the calculator, which was the normal CDF. The only thing gonna be different is what we enter in for standard deviation. All right, so let's look at this problem over here. So if you look at the problem, it says mu is equal to 70. It says sigma is equal to 20. It says n is equal to 16, or your sample size is equal to 16. And it's telling you the distribution is normal. So since it's telling you the distribution is normal, that's important, because that means our n doesn't have to be bigger than or equal to 30. Because if I already know the distribution is normal, any sample that I collect from that population should also be considered to be normal. So for this one, we do not need to apply the central limit theorem because we already know the distribution is normal. So any sample size we collect from this distribution should also be normal. So for this one, there's no need for the central limit theorem. All right. So up next, we're gonna go to A. So in A, you kind of want to notice the subtle difference. If you kind of remember last Wednesday, when we wanted to find the probability, it was a probability of X is greater than 67. So for this one was for when N is equal to 1. But if you look at it now, instead of it just being X, it says X bar, because this is when n is greater than 1. Because now instead of just worrying about a single person or a single object, we're worrying about a group. So we want the mean of that entire group to be 67 or greater than 67. So that's kind of like your hint that telling you, instead of it being a sample size of 1, we're doing this for a group of n many people or n many objects, and we want the average of that group to be greater than 67. Any question in regard to that notation? And if you did have any question, you could always put it in the chat if you don't want to get screaming out. All right, so let's go ahead and find these probability. All right, so first thing I'm gonna go ahead and do, I'm gonna go ahead and draw this because it's easier to draw it. For that way we can find what the lower bound is, the upper bound, and so on. So the middle should always be our mean. So our mean is 70. If you look at it, we want it to be greater than 67. 67 is smaller than 70. So that means we should put it on the left-hand side. So we put 67. If you look at the symbol right here, it's pointing to the right-hand side. So that means it has to be bigger than 67. So we want to shade the right side. Everybody good so far with that portion? So let's go ahead. So for this one, we're going to do this in normal CDF. So that's in your calculator. So what we have to do, we have to put what the mu is. We have to put what sigma is equal to. We also have to put what the lower bound is. So I'm going to actually put lower. And we also have to put what the upper is. So I have to put all three of those, well, sorry, all four of those things. So for mu shouldn't be that hard. Mu is just our mu, so we put 70. Sigma, in this case, what you have to do, you have to put the new sigma. So you can't put the standard deviation that they give us, because the standard deviation that they gave us, that's for if our sample size is 1. So you can't put sigma is equal to 20, because that will be that we're telling it that our sample size is 1, which is not. So what we have to do, we have to give it the adjusted standard deviation or the standard error. So we have to do 20 divided by square root of 16, where 20 divided by square root of 16 will actually just give you 5 if you do that in your calculator. So then what we want to go ahead and do now, we want to go ahead and look for the lower bound. So the lower bound, if you look at the lowest part that gets shaded, is that part right there. So the lowest part that gets shaded will be 67. If you look at the highest part that gets shaded, if you look at it, it doesn't really have a cutoff. You keep on going to the right-hand side. So technically it's going all the way to positive infinity. But in your calculator, you don't have a function for positive infinity. So we're going to put positive 10 to the 10 power. Any question in regard to that so far? Okay, so right now what I'm going to go ahead and do, I'm going to transition over to the TI-83 and 84. For that way you can see how to input it into the TI-83 or 84. So new share, TI-83, 84. All right. So right now everybody should see the TI-83, 84. So let me get clearer. So first thing you want to do, you want to hit the blue button that has second. And then you want to hit the VARS or VAR button. And then if you look right here, it says normal CDF. So if you put lower, lower will be 67. If you look at upper, upper I already have it 10 to the 10 power, but in case you don't know how to put 10 to the 10 power, you do it again. So you put 10, so you hit 1, 0. And then if you look at the button, right above the division sign, it will be that arrow. And then you put 1, 0, and then you're done. So then you put mu, mu is 70. And then you put sigma, sigma is 5. Then you go over here and paste. Hit enter. And you get that the probability that x bar is greater than 67 is equal to 0.7257. There. And that's it.
Quick question. So the TI-83, I think we just enter in the numbers separated by commas, right?
Yeah. Here, I'll show you how to do it in the TI-83. So in the TI-83,
Oh, it looks like that.
yeah. So it should look. So yeah, so for the TI-83, it will look like this. Yeah, so for the TI-83, it will look like this. So if your TI-83 look like this, all you have to do is enter. So you put 67, put comma, and then put the upper bound, which is 10 to the 10 power. Then you want to do comma, and then you put mu. So mu is 70. Then hit comma, and then you want to put your standard deviation, and we got standard deviation is equal to 5. So then you close that, and then press enter. Any question in regard to how to enter into the TI-83? All right. So if you're having trouble how to put 10 to the 10 power, you just have to hit 1, 0. And then right here where it has that arrow, so the arrow should be right above the division sign. So if you look all the way to the right-hand side where it has the division sign, multiplication sign, the subtraction sign, the addition sign. If you look right above the division sign, you should see something pointing up. It's also right below the clear button. So you press that, and then you put 10 power. All right. And that's how you put 10 to the 10 power. Any other question? Wait. All right, so let me transition back to my notes. All right, so up next we're going to do probability that X bar is less than 72. The first thing I'm going to go ahead and do is draw this out. You to kind of help me out. In the middle, we're going to put 70 because 70 is still our mean. So for this one, if you look at it, we want the X bar to be less than 72. So less than 72, 72 should be to the right of 70 because 72 is bigger than 70. If you look at it, we want it to be less than 70. Oops, I accidentally put 70. So if you look at it, it says that we want X bar to be less than 72. So if we want it to be less than 72, you want to shade the left-hand side because that's what less than 72 means. It means we want numbers that are smaller than 72. So number like 70, 69, 50, 40. We want all of these numbers. So far, everybody go with the drawing. All right. So up next, we're gonna go ahead and do, we're gonna go ahead and figure out what are we gonna enter in for normal CDF. So for normal CDF, we wanna figure out what the mu is, what's the sigma, what's the lower, and finally, what will be the upper. So for the mu and the sigma should be easy because I already found the mu and the sigma for A, so they should be exactly the same because nothing has changed. My mu is still 70, sigma, well, the standard deviation is still 20, and my n is still 16. So mu will still be 70, sigma will still be 5. The only thing that's going to change is my lower and my upper bound. So for my lower, I have to see what is the lowest value that gets shaded. So if you look at what I shaded, it pretty much keep on going all the way to the left-hand side. So this is my lower. So my lower, technically, since it keep on going to the left-hand side, it's going to negative infinity. So you put negative infinity. But just remember, our calculator doesn't have a button for negative infinity, so I'm going to put negative 10 to the 10 power. Up next, we're going to do the upper bound. So for the upper bound, I have to look at what is the highest number that gets shaded. So the highest number that gets shaded is 72. So you put 72 there. So far, any question in regard to the mu, sigma, lower bound, and my upper bound? All right, so let's go ahead and just transition over to the calculator. And let's see what does the calculator give us. So first thing I'm gonna do, I'm gonna hit the second button. I'm gonna hit VARS. All right, and I'm gonna choose normal CDF. So if you do have a TI-83 or 84, just remember it's not gonna pop up this way. In yours, you actually have to manually input it. So you put 67, comma, 10 to the 10 power, comma, mu is 70, so put 70, comma, and 5, comma. Well, for me, I have to change the lower and the upper bound because the lower and the upper bound has changed. So for the lower bound, we're going to put negative 10 to the 10 power. So put negative 10 to the 10 power. For my upper bound is actually going to be 72. And then pretty much for mu is already the correct mu. For sigma is already the correct sigma. So I'm going to go over here to paste. So if you do have the TI-83 or, well, if you have the TI-83, this is how you want to input it, where you put negative 10 to the 10 power, comma, 72, comma, 70, comma, and then 5. Any questions? What's up?
So how do you know the mu?
Well, in this problem, they tell us the mu. Because if you have the notes, if you look on top, it says mu is equal to 70, sigma is equal to 20, and n is equal to 16. So the mu was given to us. Yeah, they should always tell you what the mu is.
Okay, cool.
Any other questions? All right, so let me press enter and let me get my answer. So if you look at it, we get 0.6554. So let's put that answer. So let's say probably X bar is less than 72 is 0.6554. Cool. All right, and that's it for the part B. Any question in regard to part B? So let me just switch it over for that way you can see the answer. All right, so if you look over here, here is the answer. So the probability that X bar is less than 72 is equal to 0.6554. Any question for B? All right, so let's go to C. So if you look at C, it says find the probability that X bar, or the sample mean, is greater than 77. So I'm gonna go ahead and draw this again. So let's do this in black. So the middle should be 70. So if you look at it, it says X bar is greater than 77. So we put 77 over here because that's our X bar. And we want to put greater than 77. So if we put greater than 77, that means the right-hand side. Any questions so far on the drawing? All right, so let me go ahead and do what you're gonna input for normal CDF. So for normal CDF, you have to figure out what do you want to put for mu, what do you want to put for sigma, what are we gonna put for the lower bound, what are we gonna put for the upper bound. So for mu and sigma, since we already calculated it 2 times already, it's still gonna be the same. Mu gonna be 70, sigma is gonna be 5. Right. So for the lower bound, you just want to look at what did I shade, and you see what the lowest value that I shaded. So if you kind of look over here, where I have the arrow, that's our lower bound because that's the lowest value that gets shaded. So you put 77. If you look at the highest value that gets shaded, if you look at it, there's no cutoff. So if there's no cutoff, that means you keep on going to the right-hand side. So since you keep going to the right-hand side, that means going to positive infinity. So that means you want to put 10 to the 10 power. Any questions so far on that drawing? Well, on what I put for mu, sigma, lower bound, and upper bound? Right. So right now what I'm gonna go ahead and do, I'm gonna go ahead and transition over to the TI-83, 84, so that way you can see how do I input it into the TI-83 for 84. So you just wanna go over here where it says second bars, go to normal CDF. My lower bound, so for lower bound, it will be 77. For upper bound, we put 10 to the 10 power. Mu and sigma will remain the same. So you go over here where it says paste, press enter. And you should get 0.8086. And that'll be your final answer for part C. Any question in regard to part C?
I have a quick question. So the drawing of the graph, that's just to kind of help us figure out the numbers. There's not much else we're pulling from that, right?
Correct. It should help you get the lower bound, the upper bound. But other than that, it also should kind of help you try to figure out like what is the probability. You should kind of be able to see like, okay, is it gonna be greater than 50%, lower than 50%? Because if you say more than half of it, you should know it should be bigger than it should be bigger than 50%. But if you say like just the tail end of it, you should know it should be something less than 50%. But yeah,
Got it.
pretty much where you're getting the lower bound, the upper bound.
Just gives us an idea of where our answer should fall, kind of.
Correct. All right. So let me transition over back to my notes. All right. So what I want you to do, I want you to do part D. So take a minute and practice on part D.
Professor,
What happened?
are we gonna have office hours today?
Yeah.
Oh, okay, because I thought you said you had to leave early.
No.
Mm-hmm.
All right. So let's try doing this one. So once again, you gotta do normal C, D, F. We're gonna say mu is equal to 70, sigma is equal to 5, lower bound is gonna equal to negative 10 to the 10 power. Okay, if you look at it, the lower half, it has no cutoff and keep on going to the left-hand side. So it should be going to negative infinity. For my upper bound, if you look at it, this is the highest number that I shaded, so that's 58. Everybody good so far with those inputs? So a bunch of you got 0.0082, so that should be right, but it's kind of make sure. Let me go over to my calculator and do that work for myself. So we're gonna go second bars. We're gonna do normal CDF. So we put the lower bound should be negative 10 to the 10 power. So you put negative, which is right below the 3, and then put 10, and then put the arrow pointing up to the 10 power. For my upper, what you want to do, you want to put the upper bound, which is 58. For my mu and sigma, I'll just leave it as is because it's the same problem for a sensor. And you get 0.0082, which most of you have said that was the answer, so good job. All right, so that's it for part D. Any question in regard to part D? All right, so let's switch over back to my notes and we're gonna do some more problems. So for these problems, you're gonna have to be able to get the mu and the sigma for yourself. And you're also gonna have to get the sample size for yourself. So it's not gonna be given to you like the other one. For this one, you have to just read the problem. All right, so for this one says, suppose a elevator has a maximum capacity of 16 passengers with a total weight of 2,500 pounds. Assume male weight follow a normal distribution with a mean of 182.9 pounds and a standard deviation of 40.8. So right here, if you look at it, they tell me the mean is 182.9. So we're gonna put mu is 182.9. They also tell me standard deviation is equal to 40.8. So you put standard deviation 40.8. Also, a very important thing they tell us, they tell me the normal distribution. So we know this is a normal distribution. And that's important because now that I know the normal distribution, I know I can find the probability for any sample size. So it doesn't have to be a sample size greater than or equal to 30. It could be a sample size of 2. It could be a sample size of 10. It could be a sample size of 20. For this one, the sample size does not matter because we already know it's a normal distribution. Any questions so far how I got that it's a normal distribution, mu is equal to 182.9 and sigma is 40.8. All right, so let's look at A. So for A, it says for this problem, do we need to apply the central limit theorem? So if I already know the distribution is normal, well, there's no need for the central limit theorem. Since we already know it's normally distributed, the central limit theorem is going to tell us if it is normally distributed. But since I already know it's a normal distribution, there's no need for the central limit theorem. The only time we need the central limit theorem if our distribution is a skewed data set or if it's a data set that's just not normal. But since I already know the normal distribution, there's no need for the central limit theorem. So we'll say no. Oops. So for this one, we'll say no need for the central limit theorem since the distribution is already normal. So that's part A. Any question in regard to part A? All right, let's do part B. So for part B, it says find the probability that one randomly selected male has a weight greater than 156.25 pounds. All right. So for this one, how many male are we randomly selecting?
One.
Yeah, one. So one randomly selected male. So for this one, we're going to say n is equal to 1. Everybody good why n is equal to 1? Okay, so let's move on. So remember, n is equal to 1 because we randomly selected one male. So in this case, since it is a normal distribution, we can actually go ahead and find the probability for this one. Because if this wouldn't have been a normal distribution, if it would have been like a skewed data set, then for this one, you're not going to be able to find the probability. But since they already told us we have a normal distribution, so we can actually go ahead and find the probability for this one. All right. So let's go ahead and find the probability for this one. All right. So in the middle, we're going to put whatever our mean is. So in this case, our mean is 182.9. So say 182.9. So if you look at it, we want to find the probability that a male has a weight greater than 156.25. So 156 is smaller than 182, so that means you should go to the left of 182. So you put 156.25. And right here, the keyword is greater than. So since we want it to be greater than 156.25, that means it has to be bigger than that number. If it has to be bigger than that number, that means you shade all of the area to the right of it. So we're going to shade the area to the right of it. So far, any questions in regard to my drawing of the normal distribution? All right. So up next, we're gonna go ahead and we're gonna go ahead and see what are we gonna enter in for normal CDF. So once again, anytime you wanna find a probability of a normal distribution, we're just gonna use normal CDF. So say normal CDF. So we're actually gonna put it the way the calculator like it. So the calculator like the lower bound and then the upper bound first. Then we put mu, and then you put sigma. So for this one, if you look at the lower bound is the lowest value that gets shaded. So if you look at my drawing, the lowest value that I shaded was 156.25. So that's my lower bound. So we'll say, oops, we'll say 156.25. Any question for the 156.25? So for my upper bound, if you look at it, is the highest value. So that's my upper bound. So the highest value, if you look at it, there is no cutoff for the highest value. If you look at it, keep on going to the right-hand side. So since you keep on going to the right-hand side, that means going to infinity. So we'll put infinity, but there's no function or button for infinity. So we'll put 10 to the 10 power. All right. And that's our upper bound. Any question for the upper bound? All right. So now let's do mu. So for mu, they tell us mu is 182.9. So let's put 182.9. Lastly, we're gonna do sigma. I'll get into that in a little bit. So if you look at mu, we got 182.9 for sigma. For sigma, sigma is going to be equal to sigma divided by square root of n. So that's 40.8 divided by square root of 1. But if you do square root of 1 is just 1. So 40.8 divided by 1 is actually just 40.8. which kind of makes sense because it's saying if we have a sample size of just 1, our standard deviation is not going to change because we didn't actually increase our sample size. The standard deviation is only going to change when you have a sample size bigger than 1. In this case, since you had a sample size of 1, our standard deviation is not going to change. Right. Any
I have a
questions?
question. Yeah.
Yeah.
For the mu or the mean, isn't that the average?
Correct.
Wouldn't that be the total weight divided by the passengers though, which is 156.25? Or I mean, I know it says mean up above, but
Well, for that one, you're going to see in a little bit where we're going to actually use that one.
okay.
Yeah. Right.
Sorry, wait.
But
How did you get the standard deviation again? Can you go over that again?
it was given to us.
Oh, from the pre. Oh, okay, because this is a B. I thought it was a. Okay, yeah, it's. Okay, that makes sense. Why do you divide it over square root of 1?
Well, that's kind of going back to the formula that sigma of x bar is equal to sigma divided by square root of n. I'm just kind of showing you if you have a sample size of 1, pretty much it is equal to sigma.
I mean, it doesn't really change anything though.
No, and that's why it doesn't change anything because it's saying like if you take a sample size of 1, a sample size of 1 is not going to change anything. You have to take a bigger sample from that population in order for it to change.
Do you require us to write it like that, like the standard deviation over the power?
No, I
over
mean,
the,
like for this one problem, I'm just showing, well, for part B, I'm just showing you, like the only reason I'm doing it is to show you how it's not going to change your standard deviation.
Okay.
Okay. All right. All right. So let me go ahead and enter this information into the TI 84. Right. So first thing, turn it on. Second thing, go to second bars. Go to normal CDF. You can actually just press 2, and it'll take you to normal CDF. So if you look at the lower bound, you get 156.25. You get the upper bound. The upper bound is 10 to the 10th power. You get mu, which mu is 182.9. And lastly, you get standard deviation, which is still just 40.8. All right, so you enter all that information over here. You go to paste, you go to enter, and that's our probability. So it's saying the probability that one singular male weight is greater than 156.25. 156.25 is 0.7432. So kind of telling us there's a good chance that if we randomly select a singular male, that male weight will be greater than 156.25 pounds. So the chance of that occurring is 0.7432. All right, but that's it for B. Any question in regard to B? All right, so let's do C. So for C, some of you had a question in regard to where does the 2500 come into play? And that's where C is kind of going to come into play. So let me transition back to my notes. All right. So if you look at C, it says, assuming a worst case scenario in which the passenger are all male, what are the chances the elevator is overloaded? Find the probability that a sample of 16 male have a mean weight greater than 156.25. So for part C, how many male do they say we're gonna randomly select or that we're gonna have a sample of?
16.
Yeah, 16. So n is equal to 16. So if we have, because if you kind of look at the beginning of the problem, or if you look at the pretty much the beginning of the problem, it said the max capacity is 16 people. So it said we could have 16 people in this elevator, and they tell you that the max weight for the elevator is 2,500. So if we have the max capacity of 2,500, but it could carry 16 people. If we do 2,500 divided by 16, you actually get 156.25. So that's where this number is coming from. So you're saying if we do have 16 people, the average weight of each person has to be 156.25. Because if it's greater than 156.25, then the elevator gonna get overloaded. If it's less than 156, then or equal to 156, then the elevator most likely the elevator will not be overloaded, it will be underloaded. So that's where the 2,500 is actually coming to play. It is saying like if that's the max weight capacity, and they tell us that we could actually fit 16 people into this elevator. If the max capacity is 2,500 and we could fit 16 people in this, if we want to find out what is the average weight of those 16 people has to be, we could just do 2,500 divided by the 16. So that's where the max capacity come into play, and that's where the max weight capacity also come into play. It just pretty much comes to play on how do we figure out the 156.25. Any question in regard to that so far? All right, so let's go ahead and draw this out. So let me see if I can just fit it in right here. So the middle should be 182.9. Over here to the left will be 156.25. And if you look at it, it says greater than, so we say the right hand side. So far, any question in regard to my drawing? All right, so if you kind of look at my drawing, you should kind of see that it should be greater than 50%, because if you look at it, it's passing this mark right here, which is the middle point. So since it's passing the middle point, you should know your answer should be something greater than 50%. So if you get something in your calculator less than 50%, well, you know you entered something wrong because it should be actually greater than 50%. All right, so let's go ahead and we're gonna go ahead and figure out what should I put in for normal CDF. So we're gonna put in mu, we're gonna put in sigma, we're gonna put the lower bound, and we're gonna put the upper bound. So if you look at mu is still gonna be the same. It's still gonna be the 182.9. So you put 182.9. If you look at sigma, since we increase the sample size from 1 to 16, your sigma should be changed. So instead of putting sigma of 40.8, you should be putting a new sigma. So you want to do 40.8 divided by square root of 16, which that would give you 10.2.
Wait, why are we putting it Divided by square root of 16.
Because that's how big our sample size is. Because they tell us that we have a sample size of 16 males. So up next, we're gonna go ahead and do the lower bound. So the lower bound, if you look at it, the lowest value that I have shaded is the 156. So you put 156.25. If you look at the upper bound, you keep on going and going to the right-hand side. So that means you go to positive infinity. But remember, we don't have a button for positive infinity, so you put 10 to the 10th power. So everybody gets so far with those notations. Okay, so what I'm gonna go ahead and do, I'm gonna go transition over to my calculator, for that way I could figure out what the answer could be. So here you go, second, bars, we'll do normal CDF. All right, so if you look at my lower bound, we can actually just leave it the same. If you look at the upper bound, I can actually just leave it the same, because my lower bound and the upper bound are exactly the same. The only thing that actually changing is my standard deviation. So we're going from a standard deviation of 40.8 to a standard deviation of 10.2. 10.2. So we go to paste, we go to enter, and we get that. So let's see. So probability that X bar is greater than 156.25 is equal to, oops, sorry about that, is equal to 0.9955. Any question? I got the 0.9955 for that one.
So basically what we would write is probability of X greater than 156.25 is, and then we would write that down.
Well, technically the X has to be X bar, because since this is a sample mean, because it's a sample mean of 16, you have to do the probability that X bar is greater than 156.25. But everything else is correct. Yeah, I actually wrote it out on my notes. So let me transition over to my notes and just look at the purple notes or the purple writing.
And if it wasn't X bar or sample size, if it was just X, that means it's just one. Right?
Correct. If you can look at the last one for B, it was just 1. And if you look at how I did it for this one, I just wrote X. But for this one, since we're doing a sample size of 16, now instead of having just the X, it actually has the X bar. So like little subtle differences. So that's part C. Any question in regard to part C? All right. So for part C, it's kind of telling us if we have 16 people in an elevator and all of them are male, they're telling us there's a high probability that that elevator most likely is overloaded. Okay, if you look at it, it's telling you there's a 99.55% chance that the weight of those 16 individuals, that the average weight of those 16 individuals is greater than 156.25. And they're telling us that's a high chance of occurring. So if you're in the elevator and you see they're all male, you might want to get out of it.
Take the stairs.
Exactly. All right, but that's it for C. Any question in regard to C? All right. So for D, there's a typo. It's supposed to say B and C, but instead I have A and B. So if you have your notes, you change that to B, and you change that to C. So for this one, you say which probability is greater, part B or for part C? So if you look at part A, we got a probability of part B, we got a probability of 0.7432. If you look at the probability for C, we got probably a 0.9955. So which of the two probability is greater? No, it's C. Because C has a probability of 0.9955 of occurring, versus if you have a single individual, the probability is 0.7432. Right. Everybody good for this last problem? All right, so let me actually stop